In this video, we will look at different ways of creating arrays in NumPy. And in particular, we will look at two different ways. In one method, we will use Python's list and tuples. And in the second method, we will use NumPy's built-in arange function. So let's open our Google Colab notebook. So first, let's create a list in Python. And this list has a few elements, 10 minus 5, 20, 25. And now we will create a NumPy array out of this. So we will call np.array. And we also need to import NumPy. And we give its namespace name generally as np, as a short form of NumPy. And this is convention that is followed by different people. So we will call np.array, and then we will pass this list, which is list 1. And let's also print it. So you see that this was the list, and it's now an ndarray, the NumPy array. Now let's create a Python tuple instead of list, and we will call it up1. And let's say this has 3579. And we create another array, np.array, and we pass it the tuple. And let's also print it. So these are here two ways of creating it using the list type data structure in Python. Either using list or tuple, both are valid. Then what happens if we change you see that all the elements here are integer. What happens if I make it, let's say one of them as floating point. And let's run it again. Now you see that all the elements have become float. You see 3 dot, earlier that was not there. Then 7 dot, 9 dot, and 5.5. So it converts everything. It promotes the type. This type promotion of data type is very important. Every element within the NumPy array must be of the same type. So here, if one of the elements is float, it will promote the integers to float as well. Now let's make one more change. Let's make one of them as complex number. Let's make it 7 plus 2j. So one of the elements is complex and one of the elements is float, and two elements are int. And what happens if I print just this? So here it's accepted in Python, elements with different types. Now we create a NumPy array out of that, and you will see that 3, which was integer, becomes 3 dot. That is, first it becomes float. Then it adds a imaginary part of the complex number 0j. And similarly, all the elements are converted like that. And this is the value that we passed, but we did not pass the imaginary part for other numbers. So it had added 0 as the imaginary part of that complex number. So here also the elements are being promoted. Now we can do up1, which is the Python tuple, times 5. So what will happen in Python if we do arithmetic operation like this on list or tuple? This is treated as replication of that. So it replicates that tuple 5 times. This is the tuple till 9. And then it repeats itself 5 times within that same tuple. And this is used a lot. For example, if we want to create a list of 5 zeros, then we write it like this. And it duplicates that. The same thing is done here with the tuple. The entire tuple is being duplicated. And same will happen with the list as well. you can see the same things. The same list is duplicated 5 times. Now let's print this ARR2 once again. So this was the NumPy array. Now let's do that same thing on this NumPy array and see what happens. So you see that it's not duplicated. This list, this array remains as it is. Only thing is that it does element wise multiplication with this 5. So 3 becomes 15. This imaginary part is 0, so it remains 0. Then 5.5 becomes 27.5, and all the elements are multiplied by 5. Now let's see the other methods of creating NumPy array. We will be using NumPy's arange function. So ARR3, let's call it. Oh, we forgot to print it. Let's print it as well. So you see it creates an NP array, NumPy array of size 15 with values from 0 till 14. So this is the syntax for this. This is a mandatory parameter. There are two other parameters which we will see shortly. This is where to end, and it will end one position before it, and it starts from 0 if you don't pass a start parameter. Now let's do the same thing, but this time we will pass the start and end both parameters. Let's say I want from 10 till 24 or 25. So here we have given it where to start and where to end. Here we had given just where to end, one less than this. And let's print ARR4. So it starts from 10 and goes till 24. Now there is one more optional parameter. So this was also optional. If you don't pass it, it will start from 0. One additional thing is that you see that the difference between each element is 1. Here also the difference is 1. But you can control that. You can pass a step size. Let's take the same example, 10, 25, and this time we give it 5. So take a step size of 5 and print ARR5. So you see it starts at 10. This is inclusive. If you would have given 11, it would have started from 11. So it starts from 10, then increments by 5. So next is 15. Again increments by 5, 20. Again increments by 5, it's 25, but that is equal to this, and this range is never included. So let us start it from 9 and see the difference. So it's 9, 14, 19, 24. So this time the last element is 24 and not 25. So 25 will never be included. So here it goes till 24. So this is the step. And you can also pass it with named parameter. Instead of this positional arguments, you can pass named arguments as well. So let me take that example as well. np.arrange. And we pass the same thing, 9 and 25. But this time we explicitly give step equal to 5. And print ARR6. So this does the same thing, and this third parameter is anyway taken as a step size. So here we have passed it as named parameter, and we can also ignore it. Then it will start from 0. So 0, 5, 10, 15, 20. So these were the different ways of working with arrays in NumPy. So we will continue our discussion where we will see more operations that can be performed with arrays of different dimensions. Here we were working with just a 1D array, and in previous video we had already seen how to reshape the array into 2-dimension, 3-dimension, or even more dimension. So we will be dealing with more in our future lessons.